Alright, this is part 2 of solar eclipses. So yeah, you can see planets and stars close to the sun. You can also see something called the sun's corona. Becomes visible during solar eclipses. So here is the diamond ring effect. You see that last bit of light, you can see around the edges there. Looks like a diamond ring. Here's another one. Shows the diamond ring effect around the edges of it. This one you can also see a prominence here, one up here. Around the edges, they usually show up as little red things. Here is the corona, or the crown of the sun. We're going to talk about this because we're going to talk about the sun in detail later, but this is the outer atmosphere of the sun, and it changes shape depending on how many sunspots. This is when it's very sunspot active. You see there's a lot of projections and stuff coming off of it. This is when there's not many sunspots around the sun. This is when the sunspots were very active, and so you have these things called jets and streamers coming off the sun. The corona does not make a nice circular crown in the sky. Maybe imagine to ancient people that didn't know what was going on, and all of a sudden the sun got really dark and disappeared. The sun doesn't actually go away, it just becomes black, and you can still see its outline, which is scarier than if it just disappeared. It's like somebody took a black hole and put it in place of the sun. This is a picture I took from the Nebraska eclipse. And this is what it looked like at that time. I wanted to show you because these were prominences that showed up around the edge here of the eclipse. This is one I just like because this was taken in Africa, and it shows the solar eclipse. And this is how it looks. It looks like you see this corona around it. You see the black hole where the sun used to be. This is the planet Mercury showing up in the picture. And this is a composite where he showed the whole thing as it goes in and out of the sun, and then totality in the center with the corona. And then when we talked about an annular solar eclipse, I actually saw this annular solar eclipse too. This is in New Hampshire where I saw it. I was living in Boston at the time. I was going to get my PhD in astronomy from Boston University. And so we knew this annular eclipse was coming through New Hampshire, so we took some telescopes from the astronomy department and caravanned up there, a bunch of us grad students, and set up off the side of the road to watch this eclipse. Now we had to have special filters around our telescopes and in front of our eyes because you see even at totality, the sun never completely disappeared. It got darker by 98% of the light, meaning 2% of the sunlights are still coming through, but 2% is still just made it into a twilight kind of thing. We set up off the side of the road, and these people were driving by, and they were like looking at us like what we were doing, or honking, like, what are you guys doing? And we were watching this solar eclipse. We also went to I watched the annular solar eclipse in New Mexico, way back, I think it was 2012, either 12 or 11. And we were off to the side of the road watching this annular solar eclipse, and these people would stop by. A couple of people stopped by, and there was this one Navajo lady that said, "Oh, there's a solar eclipse going on." And I said, "Yeah, you want to look at it?" She said, "No, I don't want to look at it." But she was scared because their tradition was, if there's a solar eclipse, you couldn't do anything. If you did something, then something bad would happen to you. So she just sat in her car over there during the whole solar eclipse until it ended, and then she drove off. But I was like, okay, and she didn't want to look. We had binoculars and telescopes to actually look at it. I was taking pictures of it. And she was like, nope, don't want anything to do with it. So different cultures have different views of eclipses. All right, here's two different annular eclipses. Notice how the sizes of the moon and the sun slightly change. Because again, the Earth is not in a circular orbit either, so we get closer and further away to the sun. So the sun seems to change size in our sky slightly too, and so does the moon. All right. So, now the question is, how do you predict eclipses? Why don't we see eclipses every single month? Because we have a full moon and a new moon every month, but we rarely have eclipses. So, let me talk about that. We have to look at how the moon's orbit here is a little bit complicated. So, here's the sun. Here's the Earth going around the sun. And then we have the moon going around the Earth. Now when the moon goes around the Earth, it goes on its own plane. So here's the moon going around the Earth, but you see I drew a plane here because you can imagine the circle or the ellipse that the moon goes around makes a plane. Well, the difference is that plane right there, compared to the plane of the Earth's orbit, is off by about 5 degrees. This is the difference between the moon's orbit and the ecliptic. Remember, we already talked about that the ecliptic is the path of the sun around the sky, or you can think of it as the plane of Earth's orbit. 5-degree tilt. So what that means is that when the moon is up above the Earth, remember this is not drawn to scale, then the Earth's shadow is going to be down here, moon's up here with its shadow, it's not going to hit, it's not going to go through there. So it will not have an eclipse. When it's new, full or new, you won't have an eclipse at this time. And that moon's orbit stays like that. So over here you can see the same thing, but it's still going to be tilted this way. Here's the Earth, here's the moon. So in this case, the moon's going to be above the Earth's shadow, and here it's going to be below the Earth.